Our script mainly needs to achieve three tasks. Task number 1 is the creation of a geometrical model for our robot. This is done by exploiting the robotic toolbox by Peter Cork. Step number 2 is the creation of a suitable matrix that is going to contain all the values of the joints into the joint space. This can be done assigning to each word that we want to sample a set of given points. Those points are then going to be converted into the joint space and are going to be interpolated in order to increase the resolution of the image. All the values are then stored into a matrix, and the process is repeated for each word, adding an horizontal shift to each letter, accounting for the spacing between them.
Our letter point collection was made by using different analytical functions. All these functions are related to the trajectory of the capital lectures, and the variables of this function are the coordinates of the vertical or the horizontal position of the Cartesian plane. After this consideration, we can limit this kind of function in a specific range to get a bidirective function. After this consideration, we can interpolate our trajectory, and the accuracy of our interpolation is related to the number of points of interpolation. More is higher these parameters, more higher is our accuracy. After this interpolation, we get all the coordinates of the capital lectures, and these coordinates are the input for the inverse kinematics.
The last task is the configuration of the Arduino board and the actuation of the two servo motors. This is done using the MATLAB support package for Arduino, and time delays are automatically set in order to match the desired drawing time that is also specified into the script settings.
To test the ability of our manipulator, we tried to draw some simple images. To do that, we exploited the MATLAB add-on called Grab-it, which allows to collect some points on an image just by clicking with the mouse on the image itself. The procedure is quite simple. You have to choose your image, you calibrate the X and Y axis, and you can start collecting your points. When you are done, the points can be transferred in the MATLAB workspace in an n/2 matrix. At this point, our script will retrieve all the trajectories between the points contained in the matrix and will give the manipulator all the information to start drawing. Obviously, collecting a high number of points will result in an image of good quality. However, this will require more time to complete the drawing. With this method, we also try to write the word polito. The result was satisfying, considering also the fact that our manipulator can't detach from the plane while drawing. This was a problem when the manipulator had to pass from a letter to another one. We overcome this problem just by redrawing some portion of the letters.
Fundamental part in our project is the mechanical design done with SolidWorks. Our robot is mainly composed by 4 parts, the 2 motor supports and the 2 links. Motor support 1 is created in order to support the entire structure and make possible the rotation around the Z-axis. The 2 links instead are very similar, with a very simple and sinusoidal shape. They have some hole at the extremities in order or to fix them with big screw to the motor, or to place the pen for writing. The last piece that is the motor support 2 and is fixed to link 1 for make possible the rotation of link 2.
One of the most important parts when working on a project is the creation of a prototype. A prototype essentially is the only way we have to visualize and test everything we have designed. For the realization of this two-dimensional robotic arm, we have used a 3D printer and a software to convert the CAD drawings made on SolidWorks in G-code format readable by the printer. One of the most difficult aspects to consider when prototyping with a 3D printer is understanding the function of the various components and the effort they will have to bear. For example, in this case, the cover of the first servomotor having to support the entire structure and absorb most of the vibrations. So, this component will have to be molded with a greater feeling than the other pieces.
Have you ever dreamed of a robot so smart and powerful, capable of drawing of every size and shape? Today, our team is here to present the most advanced piece of technology that humankind has ever seen. A balanced mix of high engineering and craftsmanship to deliver you the definitive product. We present you ROBOCRAP. Dun, 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 dun.